Hi, welcome back to the Shiko SAT review series. And today, this video, we're going to continue the topic about the polynomials here. On our first video, we talk about how to combine the polynomials together, and we did 9 problems. In fact, it's a pretty easy topic. I try to combine it, so you just need to be careful about the negative signs, the distributive properties, those things. Okay, in this video, this is the place where a lot of students got confused about the topic about the polynomial. It's how to find the zeros, or sometimes we call the roots for the polynomial. So we're going to use this video to clarify some of the things, and we can take a look at a few problems, which happened in the previous SAT exam. So let's take a look. Okay, so here, this is what we did on the video number 1. So on the video number 2, and we're going to talk about the zeros of the polynomial. So we have 1, 2, 3, 4, 5. We have 5 problems, so we're going to work on. So as always, before we do that, and let me go to the whiteboard, and we're going to start to talk about a few key things about the polynomials here. All right, so let me go to the whiteboards here. All right, so in here, this is we're going to talk about the polynomial zeros, and sometimes you can call the roots here. So before we do that, I want to talk about the few key concept about the polynomial, all right? So let's take a look here. So for so the polynomial, with the single variable polynomial. So like we have for examples here. So if we have an a(n) xn plus a (n minus 1) x n minus 1, and so here this is n minus 1. So just want to make sure. So this is a(n minus 1) x n minus 1 plus a(n minus 2), and this is x n minus 2, and da da da, and to the a1 x1, and another a1 x the first power. Okay, so then plus a0. So like in here, let me see here, okay. So those things here, right? So those are constants in front of the variable, like an minus 1, an minus 2, a1, and this one should be a0. I don't know why they said like so this is a0s, right? Okay, so those numbers here, we call this coefficients of the those polynomial in front of each terms here. And then the highest powers here, the n's here, okay, this is quite important here, right? So n, this is how we define the n's here. This is the degrees. So this is the degrees of the polynomial. Okay, so like for examples here, so if I have like a f of x is equal to the 3x fourth minus 3x2 plus x minus 5. Okay, so if I have these polynomials here, so as you see, the highest powers here is 4. So I know this polynomial have what? This polynomial have a degree equal to what? Equal to 4 here. And then because so the an, that's the coefficients in front of xn, in front of the highest power. So the an's here, this is the number we called is leading coefficient. Okay, So the both leading coefficient, the degrees of the polynomials tell us a few, key characters here. So the first I want to show you what the end behavior, right? So let's see what is the end behavior for the polynomials here. What means the end behavior? That means in the graph here. Okay, so the first thing is here. So if your highest degree, if the degrees is equal to even number, all right? So that means if your polynomial have degrees is equal to the even number, and then your graph will be like this. Your polynomial graph will be the both ends are going to E. So like maybe you go like here, right? So but the both ends is going up. Or you can do like many terms here, and then the both ends are going down here. Okay, so this is when the polynomial has the even degrees. So how do I decide, the both going up or both going down? It will depend on the leading coefficient. So if your leading coefficient is greater than 0, then the both ends are going up. And if your leading coefficient is less than 0, then you're going down here. All right? So the next one's here, we say if n is an odd number, right? So if n is equal to odd, so if n is equal to odd number, then the graph also going to be like this. So that means one end going to go up and the other end going to go down here. So you can have like this was here, but one of them is going up and one of them going down. Or you can have like the many terms here, right? So like here, it's just like I see here, it's just like a many different terms here. Let's make it a little better. Graph is not good looking here. So like if you have many terms here, right? So this could be the, the polynomial. So it's one side going up, one side going down here. So how do I decide which one going up? So if your an greater than 0, then your right tail going to go up. And if your an is less than 0, then your right tail going to go down. So let's take a look at our very typical the graph here. Okay, so like if you have a quadratic, right? So for example, quadratic. So if I have like a 2x squared plus x plus 1, right? So if this is my quadratic form, because my highest degrees is 2, and here the leading coefficient is positive. So I know when I graph it, my quadratic is going to look like this. That's what you learn in the algebra. They tell you, okay, if it's go like this, if this is negative, then your quadratic going concave down, right? Okay, so then the next thing is here, if you know, like another function, like the cube function, if this is x cubes here, right? So the x cubes here, so we know the x cube, and the graph for the x cube is what? The graph for the x cube is something like this, right? Because this is the, because this is the odd degrees. So, and because the one in front of is positive, so the right hand go up, the left hand go down. Okay, so this is the first very important things about the degree. Then another things about the degree is, okay, so for polynomial with n degrees, then you have to have, then you will have n zeros, or we say n roots here. Okay, so if you have 5 degrees, then you have to have 5 roots. And that doesn't mean they are all going to be different, right? So we're going to show you what examples here. And also the roots here can be, we have the real number roots. Or we have an imaginary number root. Okay, so remember, if 5 degrees of polynomial, you're going to have 5 roots. And those roots could be the real number roots, could be the imaginary number roots here, all right? So now, let me show you, let's try to use the example we know, and let's take a look at the, okay, quadratic, all right? So quadratic here, so if this is mine, okay? So for the quadratic here, let's see here, right? So if this quadratic is, the degrees is 2, right? So if my quadratic looks something like this, okay? So then the point here, they touch here, this is what we call is the 0 for this quadratic. So for example, if this is 4, this is -2, so then I know my quadratic can be right as what? Y can be right as x minus 4, then x plus 2. Because those -2 and 4 are the numbers make it equal to 0. So we know 4 and -2 are the 2 zeros for this quadratic, right? Okay, so quadratic is degrees. So here the degrees is equal to 2. So you have 2 roots or 2 zeros here, all right? Okay, so now let's take a look at the other ones here. Okay, so the still is the same quadratic, right? So here is the, let's take a look at other examples here. Okay, so then for here, okay, so now I have here, this is my quadratic here. Let's see here, this is my quadratic. Okay, so for this quadratic, all right, it only touch the x-axis once, right? So it's only touch the x-axis once. Let's say this is 4 here. So we know it's 4. So the root is 4. But the quadratic is degrees of 2. Then you say, hey, you told me if degrees of the 2, then it is, you know, you should have 2 roots. Why? It's only have 1, right? So in here we say, yes, the roots is what? The roots is 2, but with, we call this multiplicities. multiplicity. Multiplicity. That means the multiplicities here is equal to what? Is equal to 2. That means these ones here you can write as y is equal to x minus 4 and times x minus 4, right? So this will be equal to the x minus 4 to the squares, right? So that's what we call this multiplicity is equal to 2 here. Okay, so how about I have another situations here. So like this ones here. Okay, so for these ones here, all right. So I have a quadratic function look like something like this. Let's see here. This is my quadratic. That's a really ugly quadratic. Try to draw a nice curve is not easy to draw here. Okay, so here, if I have a quadratic like this, as you can see here, this quadratic function, it does not touch the x-axis. So it does not have the real number roots. But I said the degrees is 2. I have 2 roots here, right? So what type of the roots I'm having here? So for those type of the quadratic, I'm going to have 2 imaginary roots. So what do we talk about the imaginary root? That's the one, with this complex number, imaginary number, like the square root of -1 equal to what? Equal to I, right? Do you remember that? How do we define? That means those are the roots, related to the imaginary number. So it's -1 equal to I here. Right? So that's what we have 2 imaginary roots. So it's some type of the combination of the I. So for example, could be 3 plus 2I and 3 minus 2i's here. Okay? And be careful, if if anything with imaginary roots here, if they do have roots as imaginary roots, they always what? They always come in pair. So the pairs here will just be, if one root is 3 plus 2i, then the other root has to be 3 minus 2i's here. Okay, clear? Okay, so that's what we say is the roots here, right? So let's try to take a look at another examples here. So these examples here, okay, so let's take a look. This is x cubed, right? So like I have a cube functions here, right? So we know this is a cube functions here. Okay, so this is my cube function. So I see this function is only touch the x-axis the once. But since this is a cube function, I should have 3 roots here. So in here, you can write this one is y is equal to what? X to the cube, right? So the 0 is the roots, but with the multiplicity is what? Is 3. It's a difficult word to pronounce, right? So the multiplicity is 3. That means these roots happen 3 times. So remember, right? So if it's 5 degrees, then it's what? If 5 degrees, 5 roots, right? If there is any imaginary roots has to come in the pair, right? And also the even degrees, then the polynomial both go up or go down here, right? Both go up or both go down. And if the degree is odd degree, then one go up and one go down here, right? So let's take a look at our problems here. Okay, so those are the few things we need to remember. Also, like, okay, I forgot to say here. So if the roots here, so where I can erase it. Okay, so I guess that if the roots is here, if the A, B, C are the roots, right? Then you can write the function as x minus A times x minus B and x minus C. If this is like the degrees is so if this is degrees for what? Degrees for 3s, right? So this is degrees for 3, the polynomials here. Okay, let's take a look at our problem to see we'll be able to solve these ones here. Okay, so now this one is very interesting, the problems here. So let's say that if this function have 5 distinct zeros or distinct roots, right? Okay. And which of the following could represent a complete graph of the f in the xy plane? Okay, so take a look here, right? So 5 different zeros, right? So 5 different zeros here. So let's take a look to see the number 1. What is the number 1 here, right? Okay, so now let's see here, right? So the 0 is the one where is touched the real number 0. So this is 1, 2, 3, 4. All right. So we know that both ends go up. So this has to be even like the degrees of the polynomials, right? Because both ends go up. So I have 4 roots here. If I increase, so you say, okay, maybe I have some imaginary roots down here, but I don't know. But we know the imaginary roots, right, is come in a pair. So I know this cannot be because if I have 5 distinct zeros, right? So because I know if you said the imaginary roots can be, but the imaginary roots always come in pairs. So I cannot have 5 different ones here. Okay, so this is not our choice here. Let's take a look at the second ones here, right? So this is 1, 2, right? 3, 4. So this is exactly the same again as the situation number 1. Because the both ends go up, so I know this is the even number degrees of the polynomial. So I could have 2 imaginary roots somewhere here, but I don't have 5 distinguished roots. So this one cannot be. All right. So now let's take a look at the third ones here, C here. So let's see here. So this is 1 root, 2, 3, 4, 5, 6. Oh, I have 6 distinct roots. No, I cannot because the problem does tell me I have to have 5 distinct roots. So this is not, cannot be here. So this is not the answer. Let's take a look at these ones here. So these ones here, this is 1, 2, 3, and 4. Well, you said, okay, so this has 4 roots also, right? So how can I have 5 distinguished? But look here, this is roots here because they just touch the x-axis, like the example we just did in here. This is the situations, right? So when the quadratic just touched 1 point here. So I know what is this ones here. This one could be the roots with a multiplicity equal to what? Equal to 2. That means this can have the roots with x squared or something, or x minus 2 squared something. So this could be the double roots, right? So now I count again, 1, 2, 3, 4, and 5, right? So this is our answers here. You see here? So like remember, right? So when they touch the x-axis here, so these ones here could be the the multiplications, the multiplicity of the roots. Could be 2, could be 4, depends, right? Okay, so we know this one is the possible solutions here, right? Okay, so now let's take a look at the next problem here. Okay, so the next problem here, so they say which one could be which of the following function can be the given function like this? Okay, so let's take a look. You say, oh, I have a first roots, 1 roots here. I have 1 roots here. I have 1 roots here. Okay, so then this is -3, right? So remember we say if they have the roots a, b, c, then I can write here, I would say f of x is here, right? So I can say f of x is here. These ones here would be giving me x plus 3. Right? And then this is x0, right? It's x0. And this is a 2, right? So I can have x plus minus 2. So this is not 4, right? So this is x, x plus 3, right? Okay, so just want to be careful, be clear. So this is x plus 3. Okay, so now let's check. Okay, so this is right? So if you do this, you have x, x, x. So what is your highest power here? Is x to what? X to the cube, right? So if you times that out, it's x to the cube. But for the x to the cube here, you know, because it's odd functions, right? Because it's odd functions, so I know my graph, one side has to go up, one side has to go down, right? So here, you know, you can plus the remaining term. I did not FOIL that out, but I know the top one is x cubed. That means one have to go up, one have to go down. So, but in here, my graph here should both go up. It has to be an even roots. But where that can be, then we say, okay, they must have a double root somewhere, or the root with multiplicity is equal to 2, right? So where is that? Could be here, right? So that's why I said this one's here is 2. So if this is 2, then when you multiply that out, your highest one is 4, right? So when your highest one is 4, then you know your graph matches here. So what is the answer here? So it will be the x squared, x minus 2x plus x plus 3. So this is the one, right? So this is our answer. This is such an excellent problems here, right? Because it's combined the character we talk about, the polynomials, right? So the first, you know, if you have roots, that's just like we did in the definition. If you have roots ABCs, right? All right, so A, B, C, D. Then your polynomial could be like x minus a, x minus b, x minus c, and x minus d. And the sum of those roots can be the double roots, and so it depends, but this is our basic form. If this is degrees 4, you can write it. If they give you different degrees, if this is degrees of 5, then one of them could be double roots, right? So this is a very, very good question, and you know, I think it's very good. So you need to be careful about this. That's why we say, because of the graph, if you do not put these two, then the graph here will go what? So you need to have one go up and one go down, right? So then now my both ends going up, right? Okay, so this one is interesting and very good questions here. Okay, next one is here. So the next one, I like this problem also very much. I think it's a pretty good problem to test the students' understanding. So they say the range of the polynomial. So the first things they talk about is ranges here, right? So let's see the range, right? So they say the range of polynomial f is a set of the real number less than or equal to 2. Right, so that means, so range is less than or equal to 2. What does that mean? That means y has to be less than or equal to 4, right? I'm sorry, less than or equal to 4. Then if the 0 is -3 and 1, okay, 0 is -3 and 1, so I have a -3 and 1. So that means I have to touch what? Touch the x-axis at where? At -3 and 1. Okay, so, right? Okay, so this one, oh, okay, this one obviously is not the choice, correct? -3 and 1, okay, other 3, they are all the choices here. So this one is not a choice. Also, let's say y has to be less than or equal to 4. Y less than or equal to 4, oh, obviously, this one is not because y is continue going up. And then this one here is less than or equal to 4, this end going up, so this one is not. So what is our answers here? Our answer is 8. So let's check to see if it's true or not. Okay, so they touch that -3 and 1. So this is -3 and this is 1. So that's the roots where they touch. Then y is less than or equal to 4. So here is a 4. So y is all going down, right? So that is true here. Okay, so let's will show you what do you find the roots here. Remember, if you have the real number roots, those are the number you touch it, right? Okay, so next. And so we said if the equation ax cubed plus bx squared plus cx plus d equal to 0, if this equation has roots, all right? It has roots here, -1, -3, and 5, right? And the 5. Which of the following is a factor? Okay, so remember we say if it's roots, right? So very bare minima. So you have fx's here will just be, if it's -1, it's x plus 1. And the x plus 3. And the x minus 5 here. So if they just give you roots, that's the minima degrees for the polynomial you can generate. So for these polynomials here, if you take a look, this is x here. So what happens? So the highest power is what? X cubed, right? So now they say for these functions here is x cubed. So I know, oh, okay. So this one really is the same like here because they don't have any duplicate roots or anything because it's here is the power is 3 and this one is 3 is here. So which one is the factor? Okay, obviously x minus 1 is not because there's nothing here. It's x minus 1. X plus 1. Oh yeah, x plus 1. So here this is our answer, x plus 1. Let's take a look at x minus 3 here. Okay, so let's say x minus 3. Oh, here's x plus 3. So x minus 3 is not. X plus 5. Oh, here's x minus 5. So, right? So the answer is x plus 1 here. Okay. Now, okay. So this one's here, the last problem we're going to work for this video. Let's say if the polynomial the px, the value of p3 is -3, -2. What is true about the px here? So px, you know, p3 here, right? That means I'm considering the factor x what? X minus 3. Okay, so we said p3 equal to -2. What's that mean? That means here for the polynomials here, right? If you do the polynomial, if you divide this polynomial by x minus 3, so it will be the x minus 3 times some other functions here, right? Some qx here. Then plus -2. Right, so this one's here. So when the p3, this one the x equal to 3, so it will be 0 times the qx plus equal, so plus -2, right? So that's why it's equal to -2. So that means, so what that means here, this is kind of like the similar to the long divisions, right? So if you have some px here, then here this is x minus 3. So when you do the long divisions here, the qx da 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 da, if the last things you are here is -2. That's how do we rewrite this one. See here, right? So from the long division, then we say px is equal to the x minus 3 times qx, -2. So which one is the answer? Okay, let's check here. Okay. X minus 5 is a factor of px. There's nothing, no place talk about x minus 5. There's no place talk 5. So no, this is not. X minus 2 is a factor. No, this is -2. This is not the factor, so that's not. And they say the x plus 2 is a factor. No, they did not say x plus 2 because here is like x minus 3, right? So this is just the value of p3. So this is not. So we know, so the last one is the true statement. So we know the remainder of the px divided by x3 is -2. That's what we say here. So when the p3, that means if you do a long division, right? So for the px, you can get the qx, and then you're going to have the last remainder term is -2. So that's why the px is here. So it's divided by x minus 3 and with remainder -2. So x minus 3 is not a factor. All right, so be very careful. So that's why they did not say x minus 3 is a factor. They said divide by x minus 3 right? So if it's a factor, okay, so if it's a factor, right? If x minus 3 is a factor, that means that P3 has to be equal to 0, right? So be very careful about those differences here. And so that's it. And those are the 5 problems, from the previous SAT exam. I thought those are pretty nice and very good problems and really test your concept about knowing polynomial behaviors, right? So remember, if it's even number degrees of polynomial, the both end go up or go down. If it's an odd number, what do they do? One go up, one go down. Then the 0 is very interesting, right? The roots. The number of the roots has to be equal to the degrees of that polynomial, right? So the roots could be the real number roots or imaginary number roots, right? So that's what exactly we talk about here at the beginning. So those are the very important things. So they could be the real number roots and also imaginary number roots, right? So if it's imaginary number roots, then they always come in pair. You cannot have 3 imaginary roots. So you can have 2 imaginary roots, or you can have 4 imaginary roots, but you can never have 3 imaginary roots or 5 imaginary roots, right? Then the real number roots here, you can. So you can have a double roots or duplicate roots like in here. So this root 4 that still has 2 roots, both of them is 4. So that's why we say this is root 4 with a multiplicity equal to 2. That means it's the double roots here. Okay, that's it. And I think I hope this clarify some of the concept and make sure remember those key characters about the polynomials. Okay, and that's it. It's nice to talk to you, and hope you find this video is helpful. And so don't forget to subscribe to the video. And if you want to, so you'll get notified every time when a new video is posted. All right. So it's a nice talk to you, and you have a good day. And I'll talk to you for the last videos here. All right. Okay. You have a good day, and goodbye.